Sweet. Oh, where's my speaker? That. Watch me a second. No. Let's see if that works.
Yeah, Rosie, we can't hear you if you're talking.
It's going good, going good.
All right, I'll just talk loudly. So, any questions about yesterday's stuff? Are we feeling pretty good about it? All good? All right, sweet. So, I'm going to put up a bunch that I just want you to try out. They don't take a lot of space, right? It's really just like one step of work for every single one of these. And let's call it classwork 4.1. I'm going to erase some stuff. I'll give you a spot on Canvas to upload it. But all you need to know, right? If you're multiplying, you add the exponents. If you're dividing, let's subtract them. If you've got exponents raised to higher exponents, just multiply them together. Multiply those numbers together. And you have to have the same base, right? X's with X's, Y's with Y's, A's with A's, right? This one, remember this one, right? Nothing we could do there. That's all. All right. I'll do a bunch to give you some time to try this stuff out. Easy ones, medium ones, hard ones. Let's call it classwork 4.1. 1, 2, 3, 4 at least. And I'll just put some up so you can get started. Four, 5, 6, 7, and 8. Can you guys see those okay at home? A little glary. So the first one's x squared times x to the 5th. That should be
Yo, Rosie, can you read the first one off for me? Because there's like a glare.
Yeah, it's x squared times x to the 5th. I'll probably put it like, I might just write this up and send it out to you guys too. Let me do that real quick, because then I can put it on Canvas for anybody that missed today. So let's just do 8. 8's good. Give those a shot. I'm going to put it all together, make it nice. Somewhere. Let's go here. I don't know. It takes like 10 minutes. They're pretty quick if you know what you're doing. Look back at yesterday's stuff, of course, if you need it. That's not very long. All right, I'm gonna drop the link in the chat for everybody at home, but I still have to write it up. So you're gonna see a blank dot, but I'm gonna fill it out real quick. Simplify math time. God. Sure. So there's no plus. It's all connected with multiplication. Yeah, all times. Yeah.
Yeah. I think I fixed that. I think I almost said
So
the same thing.
And these are two different. Like there's an M and an N. So you're gonna have M and N as part of your answer here.
What did I put?
You just have N. You just have N to the 6. You forgot about the M.
Oh
N
yeah.
to the 4th right there. But yeah, there's no plus signs anywhere.
Yeah.
Yeah. That's good. And then we'll talk about 8. 8's a tricky one because I put that 2 in there. We haven't really messed with numbers yet. Everything else looks pretty good. Yeah.
Okay.
Not bad. Yeah.
I have a question about number 5.
Sure.
So, since this B doesn't have anything
Yeah.
on it, is it just an imaginary 1?
It's a 1. Good.
So would it be B5 plus B1?
Right. So 5 and 1.
6.
Yeah. Good. 6. Yep.
And then I'll forget how to do this one.
If we're dividing, we subtract exponents.
Subtract them.
Yep. So 7 minus 3. Yep.
Are we gonna check these as like a class?
Absolutely. Yeah. Definitely. There we go. All right. That's on canvas. Take another minute or two if you're still working. It's all good. If you're done, hang out for a second, and then we'll talk through each one to make sure you're ready. I want you to feel like you've got it all figured out before we start messing with it and doing other stuff. Don't submit anything just yet. I'm putting it on Canvas right now, but don't submit anything just yet. I want you to fix any mistakes that we might have made. Before you do that. Yes, because 2 to the 3rd is 8. Yeah, nice. Yeah, what's up? Sure.
on, Canvas. Come on, baby. Get up there. There we go. Oh, shit. Chapter 4. All right. Now we're up to date. Sweet. And everybody's here in class. So teach. Grade 6. Everybody else is good. All right. Sweet. All right, last couple moments in case you're still working, and then we will talk these through. I'll switch colors. We know what the answers are. Should have left some space. Ready? All good? All right, so check these as you go. If you got them right, put a little check mark next to them. If you got it wrong, put a little X and then put the right answer next to it so we can compare and look back later. All right, here's what I did the first time, and here's like how I messed up, and here's how I know how to fix it. But number one, what do you think? I'll have you guys help me out. X to the 7. Beautiful. Easy one, because that one we just have to add, right? Add those exponents together. Put a little line through your 7 or not. That's up to you. I like to. Right? When we add, or we add when we multiply, right? Multiply things together, and so we'll add them up. All right. Let me see. A to the 15th power. I definitely don't want to be writing out 15 A's all being multiplied together. So I like that shortcut there, right? Exponents raise the higher exponents, just multiply them together. All right. Number 2. So like no fraction at all anymore, right? That's kind of nice. If we can get to the point where I don't have a fraction as part of my answer, I like that. Now, if I have to, and you'll see that maybe later today, we'll check that out, see if we have to deal with that. We'll deal with it. That's all good. But if I can avoid fractions, even better. All right, now with number 4, though, we have 3 different x's. Does that like mess up our plans at all? What do we get? 13th, right? Because 3 plus 5 is 7, and then 7 plus 6, x to the 13th. My lucky number. Good so far? Nice, good. All right, number 5. Now we got A's and B's. And look, you see, I'm the one drawing in the equal signs, right? They weren't there from the beginning. We're not solving anything. We're just simplifying. We're just trying to make it, like I want one variable with one exponent, and that's it, for each one. So now we got A's and B's, so what do we do? So A's with A's, B's with B's, and just kind of consider them separately? What order should we put them in? Alphabetical order, I like it. Good. Okay, so I gotta have an A and a B in there if they start with something.
I have a question
Sure.
before.
Yeah.
So do you add all those instead of I times them?
Yeah, so I know like the x's are being multiplied together, but remember the exponent is just a shortcut to tell us how many there are. Right, so I got 2 of them, and then 5 of them, and then 6 of them, so how many total add them up? Yep.
No, that makes sense, thank you.
Okay, so what's the exponent for A? 7, 3 plus 4, and that's not bad. But what about for B though? Why a 6 and not just a 5? If there's no exponent there, that's B to the 1st, right? And I know that can screw us up sometimes, but if that helps, draw in that little 1 right there, and that'll help you remember, oh, I gotta at least add one more B. You can't just B to the 5th, I had another B, so B to the 6th. Nice. Okay. Number 6. Now I got a couple of things inside, all being raised to that 2nd power. Now, that's not always going to be the case, but if you start with M and N, you're probably going to end up with M and N. Is that alphabetical order? L, M, N, O, P. Okay, good. What are the exponents of the Good. 2 times 2 is 4. 3 times 2 is 6. Done. So nice when it's just one step for each. So. Okay. Dividing now. All right. Maybe we end up with a fraction, maybe we don't. Kind of depends on what the numbers are. But just like we did with 5, 7 is pretty similar, right? We got a couple different A's, we'll put those together. A couple different B's, we'll put those together. What's the shortcut when we divide? What do we do with the exponents? And the order matters, right? We want to go top to bottom. So what's that number right there? Cool. So A to the, so blank, right? I don't even need to write the 1. So if you wrote a little 1 right here, you're not wrong. Never taken off points for you doing that. Well, we don't need it, so might as well get rid of it. Okay. What about for B? 5 minus 2. And you can see all of these ones that have like multiple variables in them. I'm not putting the multiplication dot in between, but it's there. And so if you want to do like a to the 7 times b to the 6, really like put the dot, that's cool. Adam, so
Can you explain that one more?
this 7, sure. So A's with A's, B's with B's. Just like when it's multiplication, division is just the opposite. So I'm going to stick all my A's together and all my B's together. So when I think about my A's, I don't think about it. In my mind, the B's are gone. A squared divided by A, right? Well, that's a to the first. There's no number there, like just what you told me, right? And when we divide, we subtract exponents. So 2 minus 1 is 1. Again, it's just A, right? But that's just a to the first. And then I do the same thing with the B's. Like in my mind, okay, cool, I did my A's, now I just worry about the B's. Worry about them separately. 5 minus 2 is 3. So there's my exponent value. So
then why did you use division for the A's but not for E?
oh, I did. B to the 5th divided by B squared. When I divide, I'm going to subtract those exponents. 5 minus 2 is 3. Now, this is something we did not see yesterday. Up until this point, there had never been like just a number. Okay, now remember, these are properties of exponents. Okay, these are rules when you've got variables with exponents. And the rule for us with number 6 was like, okay, like that 2 just goes to everybody inside, right? So I'm gonna do my m squared and my n to the 3rd squared, just kind of see what happens separately. And so I take that same kind of mindset with me to number 8. Like everything inside is gonna get cubed. Everything. 2 gets cubed, a squared gets cubed, b to the 5th gets cubed, and c cubed gets cubed. Now, I don't think many of us actually wrote this out, but like this is what's happening. Everything inside is gonna get that power of 3. And if writing that step helps you get this answer right, I'm a big fan. Because what a lot of people might have done is said, okay, cool. C to the 9th, B to the 15th, A to the 6th. Like they got all the variables right. But what a lot of people might have done at the beginning is wrote the number 6. Because they did 2 times 3. And I cannot blame you for thinking that thought first. But that shortcut is dealing with exponents. You multiply the exponents here. That 2 sitting in front is just a constant. It's just a coefficient. And so when that cube gets applied to every single thing inside, it's really just 2 cubes. We just got to figure out what that is. 2 times 2 times 2, which is 8. And 8 is the first number, not 6. Right? Now I can use a shortcut. Cool. Multiply the exponents, multiply the exponents, multiply the exponents, and get yourself to there. Now, you don't have to show this first step right here. But for anybody that wrote a 6, maybe now you can see why it's really not a 6 at the front. It's going to be an 8. Because it's properties of exponents. Like these are rules that govern exponents. Just 2 to the 3rd. Okay, cool. 2 to the 3rd. Cool. Before you forget, jump onto Canvas and upload. Because that's the work that we'll have for today. So I'm going to give you some points here for the 4th quarter already. Classwork 4.1. Sitting in the module, you can just go to assignments at school 2. And there's a version of it online, so you should check it out. If you ever have issues with Canvas, it happens from time to time, just let me know. You can always email stuff to me that maybe Canvas is not happy about. You know, it just spins and spins and never actually gets uploaded. Just let me know. Turn this a little bit. There you go. Sweet. Nice. Okay, cool. All right, let's slide this over. We'll keep it going. How'd you do though? Was it pretty good? You get most of them right? Good. Now we'll keep practicing this. This kind of comes up like kind of throughout this first section with properties of exponents, but there's just a couple other things that I just wanted to talk about. Yeah, 25 minutes. Okay, cool. So that's good. So we'll be able to just kind of finish up the last two properties, and then we'll put it all together. And then we'll switch gears a little bit later. So. All good? Sweet. It's hot in here. All right, I'm going to erase some of this old stuff, but we're going to use it. Well, all these same rules, we're going to go back to them. So done kind of with your practice time, kind of going back to learning these last few properties. So if you just kind of like continued your work straight down in your notes, then just kind of keep going. That's cool. If you went to a separate page for that classwork, and go back to the notes that we were taking yesterday, and we'll just kind of keep that same style going. The general stuff on the left, some examples on the right. But you're going to see that it's all going to be based on those first three, more or less. So, in general, I don't know, like right there. And then examples. This is number 4. All right, first one was we multiply, we add. When we have exponents to higher exponents, we multiply. When we divide, we subtract. And I want to lean on that last one a little bit with that whole dividing when we subtract idea. What I'm going to do is I'm going to flip it. I'm going to flip that last example that we looked at yesterday and talk about what happens right there. Now, actually, though, hold on. I want to leave a little space. My bad. I want to scoot this over a little bit because I'm going to actually write something to the left and something to the right. So I'm going to move that over like almost towards the middle because I want you to start to make some certain types of connections between the stuff that we already know from yesterday and kind of build on that. So if you just saw this and all you know is yesterday's stuff, when we divide, what do we do with the exponents? Subtract. Okay, cool. So I'm going to go left. So I'm just going to go this way. So you can get rid of fractions by just subtracting the exponents. So what's 3 minus 5? -2. Yuck, what the heck does that mean? We've never seen negative exponents before, but clearly it's something that could happen. I could have more x's on the bottom than I do on top. That's okay. But I don't want to leave negative exponents because in my mind, it just doesn't make any sense. How am I supposed to take a number and raise it to a negative second power? I'm supposed to multiply it by itself negative 2 times? What? Doesn't even make sense. Like, it doesn't mean the number is negative. But it is a little clue. And here's the thing that's probably new to everybody. Unless, I don't know if we did this in Algebra 1. It's been a couple years since I taught Algebra 1. I forget where things kind of leave off. But
What I want to do is kind of go back to my version of this from yesterday. The long one, right? 3x's up top, 5x's along the bottom. Now, I don't want to ever write this again, but I want you to see why it works. Hopefully you remember this kind of stuff from yesterday. I'm just going to put some ones up here too, just so I got 5 things up top and on bottom. And I'm not going to write them out, split apart. Remember, like yesterday, I was like, oh, an x over an x, and then another one, and then another one, and we can like break fractions apart. Well, if I can do that, I don't actually have to write it, but I can just look at it. Like that right there. What's x divided by x? Gone, right? Just it's like 1. It just divides into itself. Anything divided by itself is just 1 as long as it's not 0. All right. X over x. Gone. It's just 1. Multiply by 1 is going to change anything. Okay, x over x. Another one, just gone. And so what do we have left on top? Like these are all 1, so those don't do anything. 1 times another 1. Okay, still just 1. And that 1 is really this one right here. That coefficient I don't even have to bother writing down, but it's still sitting there. And now we need it because we ran out of exponents. Like I got nothing left up top because everything divided away that was worth keeping track of. What's left on the bottom? X times x, right? Which is x1. This and this are the same.
You have to put both of them down.
No. What's going to happen is they're going to set up either this or this to start. They're going to give us a variable that has a negative exponent, and we can't leave it like that. Or they're going to give us a fraction that has more on the bottom than it does on top. This is your final answer either way. Because the problem that we have is having that negative exponent left over when we're done. Leonard, welcome.
Sorry for the interruption.
Not at all, sir. Who do you need?
Trevor. Yeah.
On his way.
Thank you, sir.
Yeah.
10 seconds.
Yeah. Now, I want to be able to do that without all those steps in between. I want to consider this kind of setup. I'm just going to make up a new one. Let's like pick new letters, whatever. A squared over a to the 7th, something like that. And I don't want to write out all that stuff in between. I want to be able to get to the right answer right away. And so this is the part that's new, and this is the mindset that for years, when I've been teaching this, that I've literally taught Algebra 2 every year I've been teaching, so 10 years. This mindset has worked better than any of the other ones. When you've got fractions, and this actually works for like the third property too. You can kind of have that same mindset with division, which is why I always do these ones back to back. When you have division, fractions, you want to ask yourself 2 questions. And this is just, like I'm saying, this is the mindset that's worked for me and worked for students that I've had in the past. So hopefully this works for you. If it doesn't, then you can work through the way however it works for you. But when you look at something like this, right, when you've got fractions, the 2 questions that you want to ask. How to phrase it is always tough for me. Where do I have more? And in this case, where do I have more A's? There's only really 2 answers, right? Top or bottom. There's only 2 possibilities. I either have more A's on top or I have more on bottom. And the answer here is the bottom, right? Because I got 2 of them up top, I got 7 on the bottom. Well, if that's where you have more, remember what we're trying to get to. I want one variable with one exponent, that's it for each one. I don't want to end up with x's or a's on top and bottom. Whatever the answer to this question is, that's where your variable is going to go. Guaranteed. If you had more up top, then it just ends up on top. If you have more on bottom, it's going to end up on bottom. Second question. How many more do you have in that spot? So once you figure out where you have more, put the variable there. Put it on top or put it on bottom. Now the question is how many more? Well, I have 2 on top, 7 on the bottom. How many more do you have on the bottom? There's your exponent. And that makes it so much easier. So what do I leave up top? Whatever this number is right there. Coefficient. Is left over? God, I don't know how to say that. Whatever. You know what I mean. Coefficient. And that's it. And I can do that no matter how crazy these questions get. X to the 4th, y to the 7th, z to the 3rd over x to the 6th, y squared, z to the 9th. So the last thing I want to do is write x times x times x times x times y times y times y and try to find these pairs and cancel them all out. No way. What I want to do is give myself a space to work. When you're dealing with fractions, now maybe we don't end up with one. That's cool. These are the simpler ones, right? Bigger exponent on top than there is on bottom. But this is really this. B to the 4th over 1, right? Where do I have more? On top. How many more? This many. What's left on bottom? Whatever the coefficient was. Well, dividing by 1 doesn't do anything, so I get rid of it. Where do I have more? On top. How many more? 1 of them. Where do I have more? On top. How many more? 3 of them. What's left? Coefficient. Dividing by 1 doesn't change anything, so you're rid of it. So if you're here, let's go x's, then y's, then z's. And just one at a time. Take a look at your x's. Where do you have more? Top or bottom? Okay. That's where it's going to end up. Got to end up on the bottom. How many more do you have?
2.
There's your exponent. Okay, what about your y's? Top or bottom? I got more on top, because I got 7 on top, 2 on bottom. So I know my y's are going to end up on top. How many more? 5 of them. You got 7 on top and 2 on bottom, so I got 5 more. What about z's, top or bottom? Bottom. How many more? Done. I don't even need the leftover coefficient because I got stuff everywhere. The only time I ever really need this one is if I've got rid of everything on top, or like down here, everything on the bottom. Of course, dividing by 1 doesn't make a difference. But 1 on top is huge. Okay. So, honestly, in general, there's kind of two parts. Okay. The first part is this thing. Okay. Anytime you deal with fractions, yeah, subtract your exponents. Absolutely, that's still going to work. But if we end up with negative exponents, we've kind of caused ourselves an issue because now I got to backtrack and work my way through it differently. Okay. But the problem is that sometimes it's going to start as a negative exponent. Okay. If we start with
a negative exponent. We have a whole different thing we have to deal with. Well, it's the same setup, it just looks way different. And so here's the second type of thinking that we have to go. All right, so first one done. Okay, we got fractions from the beginning. Where do I have more? How many more? Done. Okay. Now, negative exponents are definitely some kind of clue that I had that issue to begin with. But I'm not gonna like make up a problem. Like I'm never gonna go really from like here, like, okay, that's the problem. They give me x to the negative second. I'm never gonna just make this one up. I don't know if it's 3 over 5 or 4 over 6 or 7 over 9. I don't know what the setup is. And so again, I want to skip all of this in between. Okay? And so here's the way that I think about it. A negative exponent is no good as a final answer. Can't use it, doesn't make any sense. But look what happens. From here, so like straight to there. Skipping all the stuff in between. What do you see? Like what happened from x to the negative second power to this 1 over x to the positive second power? Yeah. Things got flipped, reciprocal, perfect. And that's exactly what it is. A negative exponent is actually a clue that something's wrong. Something is in the wrong place. And all we have to do is move it to the other part of the fraction, from top to bottom, or even from bottom to top. If we start with the negative exponent, how should I say this? A negative exponent, I know I'm repeating myself a little bit, is a clue that your base is in the wrong spot in a fraction. All comes down to fractions. Everything about this fourth one. Okay? Your negative exponent is telling you, listen, this x, this a, this b, whatever, this 5 to the negative third, whatever, that number's in the wrong spot. That letter is in the wrong spot. And it's up to us to make the move. We actually have to like rewrite it in a different place. Okay? A negative exponent is a clue that your base is in the wrong spot of the fraction. So we do two things. Move it from, and it doesn't matter which direction, so I'm going to put a double arrow here, from top to bottom. So if it's on top, or if like there isn't a fraction yet, make one. Or if it starts on the bottom, and I'll show you examples like that, we'll just move to the top. Right? X to the negative second became 1 over x to the second. Didn't start as a fraction, so I had to make one. Because I had to put it on the bottom. If it doesn't start on the bottom, then it's on top. Right? If it doesn't start as a fraction, I got to make it. But what happened to the number? Oh, first question. Yeah, Adam.
So just put it on the opposite side. It's on the top, on the bottom, on the bottom.
That's it, exactly. Yeah, so we're just kind of working within one fraction. We're going to move it from the top to the bottom, or from the bottom to the top. But something about the number switch, too. Exactly, we switch the sign. It goes from being a negative to a positive. Make the exponent positive. Because that, to me, makes a heck of a lot more sense. Like, oh, 2 to the negative third? I have no idea what that means. But 1 over 2 to the positive third? Oh, okay, that's just 1 over 8. I can do that. And never leave negative exponents as part of the final answer. Ever. If you were in my class during second or fourth period in my calculus class, we are doing exactly this with calculus.
We're starting with fractions. We're starting with negative exponents. We're doing some calculus to them, but they are making those switches like that. 1 over x to the negative third. Nope, x to the third. X to the negative third. Nope, 1 over x to the third. They're making that switch because negative exponents just don't make any sense in my mind. They don't make any sense. Cool. I know it's new. I know it's kind of crazy and weird, but that's the way that works out. All right, one more quick one, and then I think all I'll have left are fractional exponents. We'll do those tomorrow. Real quick, let's do number 5. Catch it. Oh, man. Oh, disappointed. All right. Number 5. Probably should have left those up, but that's all good. Be right here. All right, last one. Let's get a new color. Maybe the blue will stand out. Number 5. That's not bad. All right, again, I'm going to leave a little space right here for my example. X to the third divided by x to the third. All goes back to that third property. What do we do with exponents when we subtract? When we divide? God, I'm the worst. Subtract. I'm going left. What's 3 minus 3? X to the 0. Okay, forget about that. What's anything divided by itself? In general, x to the 0 is 1. It doesn't matter which version I use. X to the 5th over x to the 5th, that's still x to the 0, and anything divided by itself is 1. That's really what x to the 0 means. You had the same thing top and bottom. Actually, that was pretty quick. Let's do number 6, because I won't be done, then we can just practice. This one's a little crazy. This one's weird. So I'll teach it to you today. I'll reteach it tomorrow. We'll practice. We'll deal with it. This is not really more of a simplifying kind of thing. This is just the last one. We have positive exponents, negative ones, 0. But all of our exponents were all nice. 1s and 2s and 3s and 5s and 10s, whatever. What are the kind of numbers we're missing? Decimals and fractions. I'm only going to focus on the fractions because every decimal can be written as a fraction. Not every fraction can be written as a decimal, right? Not a nice one. But we're not going to have like weird like x to the square root of 7. That's crazy. But what we are going to have is x to a power that's a fraction. Okay. The way that it works, and I'm doing the in general part first, I know. Fractional exponents actually have 2 parts to them, the top of the fraction and the bottom. The top part is the power. The bottom part is the root. And so if they give us something like x to the 2/3, we're not going to leave it like that. We're not going to leave it as rational exponents. We're going to change it like this. There's going to be a power attached to that x. Okay, so this has an x squared power in it. But around that is a root. There is a cube root around that x squared. Power over root. This is our final answer. And that's crazy. But it's true. Fractional exponents just have 2 parts. The power on the inside, but the root on the outside. And that's all the properties. That's it. I'm going to stop right there. I think that's good. Okay, we got a couple minutes, or we got 30 seconds. Chill for a little bit. Tomorrow we'll come back. I'm gonna talk about all three of these, really kind of four, because there's kind of two parts to that first one. Talk about them again, give you a chance to practice, see how things go. But like that's the first section, is just properties of exponents. Third. So say that again. Yeah. Okay. There you go.
Oh, yeah.
So he was getting so.
Thanks, everybody. I will see you mañana.
How was he?
How you doing, girl?
Nothing much.
You coming to see your boy, or you coming to see me?
Both.
Yes. At least I'm part of that.